Hi everyone, today we're going to do lesson 2 of unit E. We're going to look at what does the m and what does the b do in the equation y equals mx plus b. Question number 1 and 2 ask us what the m and the b do in the equation y equals mx plus b. Let's begin by looking at the equation y equals mx plus b and break it down in terms of what we know. We already know that the m refers to the slope. And if we think about the slope of a line, the slope will tell us how steep the line is. The slope will also tell us if the line has a positive or a negative correlation. Meaning, does the line go up from left to right, or does the line go down from left to right? So this tells us a little bit about the direction that the line is traveling. The b is known as the y-intercept. We've previously called it the initial value when we were only looking at the first quadrant. Now, as the y-intercept, it means where the line is going to cross the y-axis. So the b value tells us just that. It's like, where is this line anchored along the y-axis? So the m tells us the steepness and the direction of the line, where the b tells us the y-intercept, or the place that the line is anchored on the y-axis. This question asks us to describe the line y equals 4x plus 2 and how it would look on a graph. Looking at this equation, we can see that the m value, or the slope, is 4. This is a pretty big m value, so this means that the line is going to be steep. It's a positive 4, so we know that the line is going to be going up from left to right or have a positive correlation. The plus 2 at the end is our b value. This tells us that the line will be anchored at positive 2. So the y-intercept will be positive 2, and the slope will be up 4 and over 1. We can see by the graph that this line is really steep and that it does in fact have a y-intercept of 2. Question number 4 asks us, how would the line y equals x plus 3 be different from the line y equals negative 5x minus 1? Looking at the y-intercepts, we can see that the first line is going to have a y-intercept on the positive part of the y-axis, where the second line is going to have a y-intercept in the negative part of the y-axis. We can tell from the slopes that the first line is going to have a positive slope, so it's going to be going up, but it's not going to be a very steep line. It's going to go up 1 and over 1, up 1 and over 1. Our second line, though, is going to be pretty steep. It has a slope of negative 5 over 1. So this slope is going to be going down 5 and over 1 each time. This line is going to have a negative correlation. So the second line is steeper than the first line, but the first line has a positive y-intercept, while the second line has a negative one. The first line has a positive slope, so it's going up from left to right. The second line has a negative slope, so it's going down from left to right. Question number 5 asks us what we know about horizontal and vertical lines and their equations. We know that the points along horizontal lines are all going to have the same y values. So the equation of a horizontal line is going to be the value of those y values. So it will be y equals whatever that y value is over and over and over again in all of the points. Y is always going to be equal to that number. Similarly, in a vertical line, we know that the x values are all going to be the same. That means the equation is going to be in the form x equals whatever those values are. Horizontal lines have slopes of 0. They have no steepness, they're flat. Where vertical lines have an infinite steepness. They're so steep they've become vertical. So they're going to have a slope of infinity. Or sometimes we just say that the slope of a vertical line is undefined. We also know that the values that x and y is equal to in our vertical and horizontal lines is going to depend on its intercept. So a horizontal line will have the value y equals whatever its y-intercept is, where vertical lines will have the form x equals whatever the x-intercept is. Question 6 asks us how we could change the m and the b values in the line y equals 2x minus 3 so that the new line would always be lower on the graph. In order for this to happen, it would need to have a lower or a smaller y-intercept. So if our original y-intercept is -3 and we picked a smaller one, say -5, then we would have a line that began lower on the graph. For it to always be lower on the graph, the line would have to be parallel. So the slope would have to be the same, or 2 over 1. So our equation of our new line would be y equals 2x minus 5. Good luck with your work with y equals mx plus b equations. Don't forget that the m is the slope, and it tells you about the steepness and the direction of the line, and the b value is the y-intercept, and it tells you where the line crosses or is anchored along the y-axis.